Hello, you're welcome back. Alright, so we'll continue from where we stop. Now, here in this tutorial, we're going to be looking at classification of waves, please pardon me. Okay, so we're going to be looking at different ways a wave can be classified. Okay, now wave can be classified in the following way. A wave can be classified as either as a mechanical wave or as an electromagnetic wave. Right, that's one classification. Now, that classification is a wave can be classified as a progressive wave or it is a stationary wave. Then thirdly, a wave can be classified as a longitudinal wave or a transverse wave. So we are going to be looking at these three different types of classification. So let's start with the very first, mechanical wave or electromagnetic wave. Now, what's a mechanical wave? Now, mechanical waves are waves that require material medium for their propagation. Okay, so that simply means that they need material medium, and material medium that we have, there are three material mediums, okay, that a mechanical wave can actually travel through or propagate through. Okay, they include um, solid, gas, liquid. Okay, so without this material medium they cannot actually propagate. Example is sound. All right, ripple that is generated when water is being disturbed. Of course, water is the medium. Now for sound, okay, sound can travel through air or it can travel through solid. Okay, when solid is being set into vibration, okay, it can also travel through liquid. All right, so now you discovered that uh, the sound that you hear when you actually listen to someone, okay, of course, actually get to your ear, transferred to your ear through the air particles vibrating around that particular region. Okay, so without that air particles transferring the sound to your ear, you will not be able to hear the sound. All right, and another is vibrating string. When string is being set into vibration, of course it will produce a tone, which is also sound. So mechanical wave require material medium for their propagation. But unlike electromagnetic wave does not require material medium for their propagation. Okay, so which simply means that they travels in a vacuum. So they don't need gas, they don't need liquid, they don't need solid to travel. Okay, so now let's look at example. Now I'm not just giving example. Okay, I'm gonna list all the electromagnetic wave. So electromagnetic waves, okay, they are abbreviated using the acronym RELOS-Chi. Okay, where R represents radio wave, I represent infrared, L represent light, U represent ultraviolet ray, white U represent gamma ray. Okay, so all these arrangements are arranged according to the increasing frequency. So the lowest of them, okay, don't forget the acronym. The acronym is RELOS-Chi. So it's very important for you to note. So start the lowest frequency is radio wave. All right, from a radio transmission station, right? We have infrared from phone, okay, short distance transmission. We have light, that is visible light, okay. The light there, the L there is visible light. Not all light are visible, okay, but we're looking at the visible light. Then 4, U, ultraviolet ray, ultraviolet ray from the sun, okay. Basically, then of course have the X-ray used to scan the internal organ of human being. All right, and the last but not the least, we have the G, which of course is the gamma ray. All right, So now, as I said, they are actually arranged according to their increasing frequency. So the highest, the one with the highest frequency is gamma ray. Okay, so the frequency is increasing from the top, okay, to the bottom. So gamma ray have the highest frequency, and because it has the highest frequency, okay, it also possesses the highest energy. Okay, so it possesses the highest energy. Why? Because according to Albert Einstein, energy, okay, of an electromagnetic wave is given as hf. All right, so it is proportional to frequency. Now you know very well that velocity, okay, of a wave is given as wavelength multiplied by frequency. So if I should make wavelength the subject of formula, it's called that velocity, wavelength is equal to velocity divided by frequency. That from conclusion, okay, we can simply say that wavelength is inversely proportional to frequency. So if I say that gamma ray have the highest have the highest frequency, okay, invariably it will have the lowest wavelength, okay, lowest wavelength. So as frequency increases down, wavelength actually decreases, because wavelength, okay, is inversely proportional to frequency. I hope that is well understood. All right, so let's look at the next classification of wave: progressive or a stationary wave. Okay, when is a wave said to be progressive, or when is it said to be stationary? Now, a progressive wave is simply made up of just a single wave. Okay, now that single wave, there's a continuous transfer of energy from one place to another from a source. So the wave starts from a source, and it continues transferring the energy, and it doesn't return back to the source. Such is a progressive wave. It's progressive in nature. So by diagram, I can actually use this. Okay, the diagram of wave, the graph of wave, okay, that I gave previously is actually the graph of a progressive wave. It starts from a source. Of course, this origin is the source. It actually moves progressively with time. It doesn't return back. Just one single wave, okay? All right. Now, this is for progressive wave. Progressive. But what if it is a stationary wave? Okay, now for stationary wave, a stationary wave is simply made up of two identical waves traveling in opposite direction. A stationary wave is made up of two identical waves traveling in opposite direction. In fact, a stationary wave is gotten from a progressive wave when a progressive wave actually encounters an obstacle. Let's say this wave comes to this point and encounters an obstacle. What happens? It actually returns back in opposite direction. Okay, the same wave, but travels in opposite direction. So this is a stationary wave. Okay, so the progressive wave now becomes a stationary wave. Or better still, I could draw that. Okay, let me bring that down. Let me copy that and bring it down here, so that, okay, so this progressive wave, here it goes. Okay, so let's say there's an obstacle. All right, so now once that obstacle actually is being generated, then the wave, another wave, equal and opposite wave is generated. Okay, so I hope that is well understood. Now let's get to the next classification of wave. Okay, now before we even get to that point, okay, so now for a stationary wave, the point where the two wave meet, okay, the point where they intersect, that fixed point is a point that is known as the node of the wave. So please take note of that. This is the node of the wave, where the point of where the maximum displacement of that wave, okay, is called the antinode. So this is the antinode of the wave. So now the distance between the node, okay, the distance between consecutive node and antinode is what we refer to as is up to a quarter wavelength. Okay, because of course this is from this point to this point is half wavelength. So just half of the half wavelength. That's where you have this is a node, this antinode, okay? So that distance is a quarter wavelength. One wavelength divided by 4. All right, so I hope that is well understood. Okay, so let's proceed to the last but not the least classification of waves. So here I have transverse wave or a longitudinal wave. Okay, now a wave is said to be transverse wave, okay, if the vibrating particles travel in a perpendicular direction with the medium. If the vibrating particles travel in a perpendicular direction with the medium. Okay, so now such wave, okay, is generated basically. Let's look at example. There is a standing water, okay, whose medium is perpendicular and it is being disturbed. Now, by disturbing the standing water, you discover that the particle vibrates and of course move in a perpendicular direction. Such form of movement, okay, actually generate what is known as transverse wave. So this is a transverse wave. Both the particle and the medium are perpendicular in direction. Okay, so if that being the case, okay, then I will simply say that example, okay, a very simple example is what I just given now, water ripples. Water ripples. Water ripples is one example. All electromagnetic wave are all transverse wave. All electromagnetic wave are all transverse wave. All right, so then what now happens to longitudinal wave? Longitudinal wave. Okay, so in longitudinal wave, both the vibrating particles and the medium, vibrating particles, okay, travel in the same direction with the medium. They are in the same direction. And a very typical example is sound. Okay, sound wave is basically a longitudinal wave. All right, so these are the classification of wave. Now we are going to now discuss, okay, we're going to look at the equation of a progressive wave. Equation of a progressive wave. All right, of course, you know that every progressive wave can be represented by a graph in which there is a transfer of energy by continuous vibration of the particles, okay? And this vibration of particles happen in such a way that the graph becomes a periodic motion, okay? So this is going to be a graph of the wave motion with time, the vibration of the wave with time. So y against t. So I know very well that every graph, okay, always have an equation that actually gave rise to that graph, right? So we're looking at the graph of a wave, a progressive wave. We're looking at the equation, okay, of a progressive wave, and the equation of a progressive wave is given as y equal to a sine bracket open omega t plus phi. All right, so all these parameters, we need to list them out. A is the amplitude of the wave. Of course, the symbol here called omega is what is known as the angular frequency of the wave. Angular frequency. All right, now dt is our horizontal axis, which of course is time. All right, our independent variable, time. Then the last parameter there, phi, is the phase angle of the wave. So this is one way of expressing the equation of a progressive wave. Another way of expressing the equation of a progressive wave is by expressing the parameters, okay, of omega, that's the angular frequency, and of course phi. Right, so now the angular frequency, okay, if you have treated circular motion, is always given as 2 pi f, okay, 2 pi multiplied by the frequency. So that's the relation between the frequency of a wave and its angular frequency. All right, 2 pi f. And this phi, which is the phase angle of a wave, is always given as kx, where that coefficient k, all right, is actually is a parameter known as the wave number of a wave. Let me bring that down here. Wave number of a wave. And the wave number of a wave is always given by 2 pi all over the wavelength of the wave. So now that way, apart from this, I can also express the equation of a wave this way by putting the value of both the omega and the wave number, okay, and the phase angle into this particular wave. So the equation of a wave can also be written as y equal to a sine bracket open omega, which of course we already know is 2 pi f, then multiplied by t, then plus the phi, which of course we know it is given as wave number multiplied by x. The x here is just the horizontal displacement, okay, the horizontal displacement between a wave that starts from the origin and the one that doesn't start from the origin, okay. Let's say wave start from here, so that wavelength, that phase angle has a displacement x from the origin. All right, so that is what that s actually represents. Okay, so now the question is, what is the significance? How do we actually apply wave equation to solve question? Now in exams, anytime you are being given any problem on equation of progressive wave. All you're just gonna do is to compare the equation that was given to you with the standard equation of progressive wave, then you can get the unknown parameter. Okay, now let me give you a typical example. For example, let's say that a wave is given, the equation of a wave is given as 20 sine bracket open 20t, then of course plus 10t, 10x, please pardon me, 10x. This is what was given in the question, and you are being asked to find the following parameters. Okay, find omega, the angular frequency of the wave, comma. You're also asked to find the frequency of the wave, then asked to find the wavelength of the wave and the velocity of the wave. It will just be very simple. All I just need to do is to compare variables. Okay, compare the variables of the wave that was given with my wave equation. So what simply means that if I want to get omega, right, the angular frequency, I'm going to compare. Remember, the angular frequency from what we had before is the coefficient of t. So comparing to with this equation, what's the coefficient of t? That's 20. So invariably now my angular frequency is going to be equal to 20. And of course, angular frequency is measured in rad per seconds. If I be asked to find the frequency, you know very well from the relationship we had, angular frequency was given as 2 pi f, right? So that means the frequency is going to be equal to angular frequency divided by 2 pi. So this is going to be equal to angular frequency already is 20, then divided by 2 times the pi. Okay, of course pi is 3.14. So you can use calculator to get that completed. Now if you're being asked to find the wavelength, you know very well that the wavelength, okay, is gotten from the wave number. So, and the wave number, what's the wave number? The wave number is 10. So invariably the wave number is the coefficient of x. So okay, the wave number is 10. And how is it related to the wavelength? We know that wave number is given as, from this formula, wave number k is always equal to 2 pi all over wavelength. So that's 2 pi all over wavelength. Okay, so that way now if I cross multiply, I'm gonna have 10 multiplied by the wave number. I'm cross multiplying, then it's equal to 2 pi. That way wavelength is going to be equal to 2 pi divided by 10. So you can break this down. Okay, so get your answer. Then find out the velocity of the wave. Velocity of the wave is wavelength multiplied by frequency. With this, from here we'll get our wavelength. We'll get our frequency, please pardon me. Here we'll get our wavelength. Then when you now multiply the two, that gives you the velocity of the wave. Okay, so I hope that's well understood. I could actually get question to actually illustrate this better. Let's look at some questions. Okay, here I have a question on the screen. Let me maximize it. Maximize that. Okay, so let me see. Okay, so the question goes this way. The equation of a wave traveling along a positive x direction is given by 0.25 times 10 to the power minus 3 sine 500t minus 0.0 0.025x. Determine the angular frequency. So that should be very simple. The angular frequency is the coefficient of t, that's 500. So the angular frequency of that wave is 500 rad per second. Okay, I should have another question. Let me mass this also. Given the progressive wave equation y equal to 5 sine bracket open 2000 pi t minus 0.4x, calculate the wavelength. 0.4x. So for us to get the wavelength, that will be easy. The wavelength, we get the wavelength from the wave number. Okay, of course you know the wave number is 2 pi all over the wavelength. So what's the wavelength wave number of this wave? Is the coefficient of the x. Let me reduce that. The coefficient of x is 0.4. Okay, so here we go. So I'm gonna have 0.4 is equal to 2 pi all over lambda. So if I cross multiply, I'm gonna have 0.4 lambda equal to 2 pi. So wavelength lambda is gonna be equal to 2 pi. 2 pi is 2 times 3.14 divided by 0.4. Okay, so you can complete that. Next question. Okay, so that's actually all for now, right? See you in the next video. Thank you very much.